Okay, so here's your second video from Chapter 5. We're still in Section 5.1. This one we're going to be simplifying integral exponents. All that means is that your exponents in all of these problems will be integers. Our first example is 4x squared minus 8x to the negative third over 2x to the negative 1. It looks like the previous ones where we've been able to move things upstairs and downstairs, but the problem here is that this subtraction on the top means we can't really move that 8x to the negative third without moving the 4x squared with it. The denominator is a little bit simpler. We can take this x to the negative first, excuse me, and move that upstairs. Since the 2 is not technically being raised to the negative first, that's going to stay downstairs. So when we move that x up, it just becomes x to the first times 4x squared minus 8x to the negative third all over 2. My next step is going to be to distribute the x. So we have 4x cubed minus 8x to the negative second over 2. Before we go any further with the exponents, we notice that all of these coefficients can be simplified. So my next line will look like 2x cubed minus 4x to the negative second if I divide out that 2. And then we're almost done. Our last step here, we need to take care of that negative exponent. We know we can't have any negatives in our answer. So we have 2x cubed minus, now only the x to the negative second is going to go downstairs. That 4 is going to stay where it is. So your answer will be 2x cubed minus 4 over x squared. This next example looks a lot like the last one, but in this case the only red flag, the only thing we're really worried about is the y to the negative fourth. Last time we had a negative exponent on the bottom as well. What we can do with this is actually rewrite this as two separate fractions. So this is the same as 3y to the negative fourth over 2y to the fifth minus 7y over 2y to the fifth. We can treat these two terms separately using our laws of exponents from the first video and go from there. So the first term, this y to the negative fourth, we know can go downstairs, which is going to leave us y to the ninth down there. So this will be 3 minus 2y to the ninth. On the right side, we have y up top and y to the fifth down bottom. We can't move anything, but we know that one of those will cancel. So we have 7 over 2y to the fourth. Since we have subtraction in the middle here, we can't do anything with our denominators. We have no negative exponents, so this is actually our final answer. This problem looks like the last two, just flipped upside down. What you may want to do is something similar to what we did in the last problem, where we can split it up like this. But since it's the numerator, not the denominator, that's not going to fly, so we can't do that. What we can do in this example, our biggest problem is the negatives. So we have z to the negative second on the top and a z to the negative first on the bottom. We know since it's addition, we can't do anything with the z to the negative first. But much like we did in the first example, if I move this z to the negative second to the bottom and get z third minus z to the first down here, the important thing here, which a lot of people forget to do, we did move everything from the top, but there's still a 1 up there. So this is really 1 over z squared and then times z to the third minus z to the negative first. Now we can distribute across here. We get 1 over and then z to the fifth minus, and when we multiply z to the second times z to the negative first, we end up with z to the first. So your final answer for this problem is 1 over z to the fifth minus z. Unfortunately, that strategy doesn't always work. Like for example, in this case, if I were to just take the t to the negative second and put it down here, when I distribute it, I'd still end up with negative exponents. So in this case, we need to go a little bit further. So if I show you the other way to do that, what we're going to do here is multiply top and bottom by the same thing. Remember, we can always multiply by whatever we want as long as we do it to both the numerator and the denominator. In this case, we're going to pick t to the fifth. You want to take your smallest exponent. Again, if we multiplied by t to the third and chose to use this term, when we multiplied, we'd still have a negative exponent. So you always want to take the smallest exponent, which in our case is negative 5. When I multiply top and bottom by t to the fifth, I end up with 3t to the third on the top. And when I distribute it on the bottom, we get t squared minus, and t to the negative fifth times t to the fifth, we know is t to the 0. We can simplify that just a little bit further. We know that anything to the 0 is 1. So your final answer for this one will be 3t cubed over t squared minus 1. We can also see these problems with numbers as bases. We have 3's here as our base instead of the t's or z's that we had in the past. I'm going to make a little more room here. I'm going to show you two different ways how to do this problem. We can do pretty much the same thing we did on the last slide. That 3 to the negative third on the bottom is our problem. So if we multiply top and bottom by 3 to the third, what we end up with is just a 3 on the top. And then on the bottom, when we distribute this 3 to the third, we get 3 to the fourth minus 3 to the 0, which is 3 over 3 to the fourth is 81. We know 3 to the 0 is 1. Our answer here is 3 over 80. I think this is the faster way to do it. But another thing you can try here is you know that 3 to the negative second is 1 over 9. Down the bottom here we have 3 minus, and then 3 to the negative third is 1 over 27. By using common denominators and manipulating the fractions a little bit, you'll still end up with 3 over 80. So if I do that quickly on the bottom here, we can rewrite 3 as 81 over 27. So here we have 1 over 9 over 80 over 27. If we keep change flip this, we get 1 over 9 times 27 over 80. And then by simplifying the fraction further, we get 3 over 80 again. So in this case, there are two different ways to do it. I think the purple way is a little bit easier, but if you're good with fractions and want to just stick to straight numbers, you can try the red as well. Your directions for the last type of problem in this video say simplify by using powers of the same base. We stressed in the first video that you can't apply any laws of exponents unless numbers have the same base. So let's take a look at this first one. We're actually going to ignore the second one on this slide. In this case, we have our bases are 4, 8, and 16. Those are obviously not the same, so we can't do anything with them yet. But if we look at the word powers, we know that all of those numbers are powers of 2. So I can rewrite 4 as 2 squared, 8 as 2 to the third, and 16 as 2 to the fourth, and substitute those right into this problem. So we end up with 2 squared to the ninth times 2 cubed to the negative fourth to 2 to the fourth to the third. Now we can apply our laws of exponents. We end up with 2 to the 18th times 2 to the negative 12th over 2 to the positive 12th. Up top, we simplify to 2 to the 6th over 2 to the 12th. We can further say that is 1 over 2 to the 6th. And when we evaluate, 1 over 2 to the 6th is 1 over 64. So the key here is the powers of the same base. So you're looking for what those numbers have in common, and you can go from there.